we will continue, if you look at the whole script, with the next component, the fourth one, which should be, I mean, in my case, it's nested loop. There is one slider connected. And please deactivate the one that we've used right now. And activate the fourth one from the top. Then you should see these rectangles placed in this grid. Okay, so the idea of this component of this code is to introduce you to this so-called nested loops, that you can place a loop inside of a loop, which sounds very trivial, but it needs some mental capacity to understand what's happening in this kind of looping inside a loop. So, therefore, we declare these first two variables, the iterations A and iterations B, which is how often the inner and the outer loop is repeated. We use this nested loop to create a grid where we have one loop to control more or less the x coordinates, and the other loop to control the y coordinates of our elements in the grid. We introduce as well a random function. So if you need random numbers, there is a predefined class called random, which you can initiate, or you create an instance of this class by this new random and with these empty brackets. Then you have an element, this R and D, that you can use later for creating random numbers. And we have a list where we collect our rectangles again. So that's what you already know. In this case, before we have had a list of lines. Now we want to collect these B-rep objects, which are the surfaces. So these green surfaces, they are created in the same way that we create rectangles, and they are then transformed into these B-rep objects. Here I see some redundant code that we create. So just for you to understand, before we use this plain world x, y object to create our drawing plane. In this case, we create a custom drawing plane, just in case that you want to draw on some other plane that you define by your own. In this case, it is the same as the x, y plane, but you could create your own plane in the three-dimensional space where you draw your rectangles onto. That's done with these vectors. So here I use the x and the y vector, but if you use here your custom numbers, you can create your own drawing plane. But this is exactly the same as we have used it. Where was it? This plane x, y, that's the same as the plane that we create here. So we could replace the whole part by this code. Then it's simplified. So that's just for you in case you need it. So you may have realized every time when I press, when I recompute the solution, it creates a new set of rectangles. That's because we use this random numbers generator. So you can do this if you go go to your canvas and press F5, or it's here the solution recompute, then it recomputes everything and generates a new set of random values. As long as you don't use a custom seed number. So the seed is where the function starts generating random numbers. So these are not real random numbers, so maybe you have heard this, heard about the logic of generating random numbers. If you put in here a seed, then the random number generator starts always from the same seed and generates always the same sequence of random numbers. So at the moment when I initiate this random number generator with some number like a 1, or you can use also an endless long number, but if it's the same number, it always generates the same sequence of random numbers. And if I don't have any number here, it's always a new seed. Okay, but the main part is coming now. That's these two loops that are nested one into the other. So an outer and an inner loop. So you can repeat this nesting as often as you like. You can do this twice as we do it here. You can do it 3 times, 4 times, doesn't matter. What you need to consider is that you need to use different variables. So far we used always this I, but that's just a convention, or I mean it's not a convention, it's just something that's usually used, that you use one letter as this variable, and usually you start with I. And here we use K as the next letter for the second loop, so that we know we have I and K that is controlled or iterated by these two loops. Then we have our two stop conditions. The outer loop is repeating itself until I is smaller than the number of iterations A, and it's increased by 1. So this is something you already know. And the same with K, same logic, same syntax, just different letter. Now, what we want to do is we want to create our rectangles. That's as we have done it in before. Therefore, we define the width and the height of the rectangle. And for this purpose, what you may see here, we use our random number generator. So the syntax is that you use this instance of your random number generator that we called RND. And with this dot, you can see what kind of random. As I've mentioned in the morning, sometimes this intelligence doesn't work. I don't know why at the moment. This time it doesn't work. You can generate two types of random numbers. One is a random number between 0 and 1. And the second one is a custom range that we use here between 0, in this case, or some starting point, some starting value, and an end value. So it generates a random number between this, or in this range. In this case, it's between 0 and max RND is 10. So we generate a value between 0 and 10. And we just add here 1. You could also start with 1, doesn't matter. That's the reason why our rectangles have different width and height values, and that they are always changing. That's because we use this random number generator. So you know already how to create a rectangle. This time we create the rectangle in a different way. Last time we created it with the drawing plane and the width and the height value, which resulted in a rectangle with the origin 0, 0 of the bottom left corner. There was a question around there how to move it to some other place. Now we create the rectangle with the information of two corners. I hope it's the bottom left and the top right corner. Just to look into it, that I don't tell you something wrong. Minus. Yeah. So this rectangle, I don't know if I see it. If you use again this intelligence, here you see the third possibility to create a rectangle is with the plane and 0.3D for corner A and 0.3D for corner B. And that's what we do right now. We define the corner at the bottom left and the corner at the top right. With this information, we create our rectangle. Now let's go back one step. In order to create this grid that we have here with these red rectangles, what we want to do is we use a reference point, which is the center of the rectangle. I hope so. Yeah. And from the center, we compute the bottom left and the top right corner point. Therefore, here we use the 0.3D as a reference point. And now you see the usage of the I and the K iterator. So we use the I, the outer loop, for the X coordinate. Means with this I, you create the information of the X position of a rectangle. And with the K, you create the Y position of the rectangles, the center points. So as you can see, the center points are in a grid. Only the sizes of the rectangles are varied randomly. I can also put this away. Oops, not good. So if we reduce the randomness, then you see we create a regular grid of rectangles. And if you want, so it's 5 by 5 rectangles or a 5 by 5 cells grid. If we change now the number of the outer loop, then our grid should grow in the X direction. I hope it's true. Yeah. That's because the I comes from the outer loop and it controls the X coordinate. And if you have the I iterator repeated more times, you create more entries on the X direction. If we do the same thing on the Y direction, you see we create 7 or 5 to 7 cells grid with this information. So that's really the key line, putting together the information that comes from the two nested loops. So what you see here, the nested loops, is used to create a grid of elements. Repetitions of the inner loop multiplied by the repetitions of the outer loop. I'm sorry, I cannot increase it more, the size, otherwise it doesn't fit into the screen. with this iteration, we have created the center points, this ref PT, the reference point for our rectangles, which is the center. And to create now corner A and corner B, we need to subtract the width and the height in order to reach our bottom left corner, and to add the width and the height in order to reach the top right corner. So here I just used the full values. Of course, this is then in the end half of the width, but this doesn't matter. And here you can then also add these random parameters again, which is then also scaling the grid. That's because we use this max R&D also to create this separator between our elements. Okay, and at the moment when we are finished with the creation of the rectangle, what we do is we convert it again to first a NURBS curve, and from the NURBS curve we create a B-wrap surface out of our curve, which gives us these filled surfaces. And these surfaces we put into our list that can store our B-wrap objects. We can at least create rectangles only for the one side. Then I think it becomes clear. This means you need to manipulate the corner B information, which is the top right. So we don't want to go to the right and to the top, but only to the top from the center point, which is the X. We need to say, yeah. So in this case, we create only from the center the left part. And if you would, I mean, we can do this as well. We can now I mean, that's the most stupidest way, just to copy and paste it, but it would work probably. That you say, okay, 0.9, then there. No, doesn't work anymore. Something's wrong. So here, now you see you created these two rectangles. I mean, it's not the most elegant way, but it works. So you have to take care why it doesn't work in the beginning is at the moment when you declare a variable like the corner A, and you say it's a point 3D, then you are not allowed to use the same, to declare the same or the variable with the same name second time. Therefore, you can overwrite it, as I've done it here. You can just use the same name, overwrite it with a new information, and the same for the other objects as well. You just have to delete the new declaration, and then you put it into the B-wrap collection. For example, the number slider and replace the number of iterations of the loop. And then you can control the size of your grid by your slider. But as you see, it always generates a new seed, new random numbers, because we have not specified the seed. If we specify the seed, the changes are not that, it doesn't change that much. So the ones that are created already, they remain the same, more or less. Not always, a few of them. But you always create the same random set. So if I move to 10, so remember how it looks here, and I move back and forth, then it's the same configuration. If you don't use this seed number, it always generates a new set of random numbers. So the idea is, I provided you these scripts that you can play around with the numbers while I'm explaining these scripts, because it doesn't make a lot of sense to retype everything, that I type it and you type it and we all type it. But when I'm explaining what happens here, it's really a good idea that you play around a little bit and try to manipulate a few of these parameters or exchange values or make some small formulas or whatsoever you want to do. And if you have questions, we can discuss it directly if something is not clear, but you only realize it if you change something, because otherwise, as I've provided to you, it works, so there is no question, no issue. The problems will arise if you do something on your own. If you want to do it a little bit different, then you will realize that you have not understood everything that looked very simple, as long as you don't have to touch it.